And if P is start, we return current paths. And yes, we can make this be a list of path, best path cells. Okay. So now we have compute best path. I don't need to recompute best path, I don't think. We're going to compute this thing as we go in the beginning. Okay. So the current path is the best path seen. If we're at the start, we're going to just return the current paths, which will be, again, list of path. Okay. So now we do this here. We're going to position is position to evaluate.dq. We're going to get current paths, which is the best paths we've seen for that. Now, all right. For every position that we've got here, if so, yeah. If not best path seen contains that key, then we're going to, and what we need to do now is we need to take current paths. All right. So we now need to create the new path. Path, new path equals, actually, so this is going to be a list of path, new paths equals current paths dot select, and the current path is going to be right. Each of those is going to be a path, which is, again, a list of positions and a cost. All right. So that's going to be CP goes to CP dot okay. CP dot route okay. CP dot route comma position, actually position CP dot route comma CP dot cost plus cost. So that gets right dot to list. Okay, so that gets us the new paths we need. So now, if that's the case, if this wasn't there, we need to say position and new paths. Oh. And that has to close off there. Okay. The type arguments can't be. Okay. Dot to list of path. Want to do that? No. Okay. List. A list of paths. Okay. Current paths is what we got from best paths seen, which should be a list of path. There we go. So the var is really what was killing me there. Okay. here we go. So we have current paths dot select CP, then the cost plus the other cost. So now, if we don't have this there, we just do that. Great. And then what I want to do here, I need a current value as well. So int current value equals current paths dot first dot cost. Returns the first element of a C. Okay, yeah. More orbital. I don't want to think about music, but I also don't want it to go away. Okay. Cannot be inferred from. What happens if we try to compile this? Like, list does not contain a definition for select, and no accessible extension method select could be found. Is select not the method that we use to do link? Have I gotten confused too much here? Enumerable.select, yes. Projects each element of sequence into a new form. And there's system.link in there. All right. Run all, because seriously, you should have that from system.link. Okay. Oh, accepting a first argument of type list of okay. Okay, so yeah, no, enumerable.select. Oh, hang on. T source, T result. So actually, this should be. Is that going to work? Okay. Yes, that works. Okay. So I was just doing the type argument wrong. Okay. So then we do, right, then we can do that. Right, and current value needs to exist because we need to get that like there. Okay. So then, otherwise, if the best paths so now we need to say, hang on. Yeah. Else, best paths equals, no, hang on, list path known paths equals best paths seen for position. Int known value equals known paths dot first dot cost. Okay. So that's the known paths for how to get here. If known value is greater than current value plus cost, replace existing paths. Else if known value equals current value plus cost, append to existing paths. Otherwise, this path isn't good enough. In either case, if we need to replace existing paths, we need to enqueue. If we append to existing paths, we need to enqueue. But now otherwise, okay, we have our best path seen thing going on here. So to replace the existing paths, that's pretty easy. Best path seen position equals new paths. But if this isn't the case, then we have to say, yeah, best path seen position equals known paths dot okay. Just concat for adding two lists to each other. Yeah, concatenates two sequences. Known paths concat new paths. Okay. Cannot implicitly convert type IEnumerable on list to system. Oh, it's an I, right. And known paths are, hang on. Known paths are a list of paths. New paths are also a list of paths. Why? Oh, right. I have to to-list that whole thing. Okay, so there's all of that. And now, once we've got that, all right. All right, so now we have list of path result equals an empty list. And anytime we reach, if we reach the start and, okay. Yeah, anytime we reach the start, we need to result dot append. So that, let me add, no, appends a value to the sequence. Result dot union. I just want to add let me just take a quick look at list systems connection collections generic list, right? Add range. Do I still have add range if I go back to .NET 8, which is what I'm actually running on? I do have add range. Okay. This is confused. That is very confused. I can no longer click on the text area in there. Oh no. It isn't even running, and I can't click on a bunch of pieces of it. Please don't do this to me. Computer, please don't do this to me. I think my computer might be doing this to me. Like, all my other apps are working fine. I'm just a little scared right now of what may be about to happen. Okay. It closed in a fairly non-freakout way, which makes me hope that it at least managed to do like buffer saves on its way out. Okay, failed to set some document metadata. Short. We don't need to save past days things. Those are all in. Okay, a bunch of this is here. Let's continue down to like here. Okay, replace existing paths append. Okay, we're very close to where we were. So if P is start, okay, cool. We want to say result.add range current paths. Save, run all, hope. Right. Not all code paths return a value. Right. Then we get to the end of all of this, and we just need to say, right, return result. And then return compute best path. Run all. Okay, so we've gotten our, so this is, here we go. We've now got the best path here, right. And what I think I just want to do here is I'm going to, yeah, return compute best path. I just want to say cells. All right, run all. Okay, it found, that's a lot of paths. That is almost 1,400 paths. I mean, how many paths are we expecting to find here? Because there's a number of them, but yeah, in the first option, there are many paths through this maze. Okay, but like, yeah. Oi, oi. Okay. Okay. So let's just go ahead and say, I think again, the thing I want to do here is, right, if P is start, int result value equals result dot first dot cost. If current value is less than result value, result equals current paths. Else if current value equals result value, result.add range, current paths. And right. Otherwise, we don't add them. Run all. Let's see, did that help any? Invalid operation exception. Sequence contains no elements. Oh, right. That is correct. If, where was that P start? we go. And now run all. We still have quite a lot of those. Okay. And yeah, the number on it is 7036, which is the number. Okay. So let's assume that maybe this is correct. We'll find out. So we have actually no. We want this to be cells. So here we go. We have so now list path best paths equals compute best path. And now what we just want to do is for each path in best paths, hash set coord best tiles equals new hash set for each path in best paths. Best tiles.union with, which is, I believe, transforming. Yep. Best tiles.union with path dot route. Right turns to those. Path dot route dot select pause goes to pause dot p. Return best tiles, and this thing should now again return a list not of paths, but a list of coord. Okay, run all, hope. Right. Return a hash set. That's the old one. A hash set of coord. Try that, run all. Okay, we found 45 cells there, which I believe is actually correct. Yep. Okay. And let's go ahead and visualize map cells. Yep, that looks good. Okay. Let's try doing, so we're actually going to comment that out, and let's just say cells.count. 45. All right, let's see if we can give this the final data, because I'd like to be done. All right, here we go. So run all, procking on the full data, coming down to the bottom. Zero. Let's try on dataset 2 and see if maybe example data 2 will, give me some sense of what's going on here. Also got 0. Okay. So tell me here, yeah, display best paths. That'll give me some kernel data about my, yeah, about those things. Run all. empty. That's interesting. Just confirming that part one there still has, yeah, that we still have the best possible score there. So that still worked. So why? I just want to collapse this here. Okay. I just want to double check here because it worked when I ran it on the first data set the first time. I want to rerun it on partial data 1 here. Run all. Okay, I do get the 45. So it works on that data set, but not others. So there's something about, there's some case it doesn't get working. Okay. So the first question here is, do we ever get to start? Okay. I just want to take a look at what that looks like on the main one here. Yeah, the main one evaluate gets to start 3 times. So what happens if we go to partial data 2? That's concerning. Okay, we never get to start because this should be doing the exact same thing as the other one. So let's go ahead. Let's go ahead and split this because what I really want to check here is how are these two algorithms differing from each other? So here we are. We walk best possible score for each of our position cost. We get that. So if it contains the key, we evaluate. Otherwise, if it is greater than the current value plus cost, we evaluate it. And on this one, also, if it is the same as current value plus cost, we also append it and actually, hang on, we tag that to in queue. I see the problem, I think. That's a loop. We don't need to reevaluate that. It's already been evaluated at this cost. Oh, but no, we... Oh, we maybe do. Let's see what happens. 64. That's correct. Okay. We're now subject to, there's a very small timing thing that could make this code non-deterministic. Well, not really timing, but it's about how things get dequeued from a priority queue, and I don't have the proof that this code might be deterministic, but it might not, but it might still be right. So let's go ahead and go back to full data. Run all. Oh, yeah, it's hitting the 10-second wall. That's part of the problem here. Let's give it 60 seconds to run. Oh, no, it's still... Oh. I bet these two windows don't affect each other. That would be really unfortunate. Yeah, you can split it, but... Or did I just do it in the wrong spot or something? Oh, yeah, I did in best possible score. Okay. Okay, no, they do affect each other. Good. That would have been deeply, deeply problematic if they just, like, totally divorced from each other. That would not be how I expect editors to behave. All right. There we are. Evaluate. Okay, so now it's found at the start at least once. Okay, there we go. It found a bunch of things, and it says there are 496 cells, which, let's see what it thinks of that. Okay, great. Return to my advent calendar. It's only 2 hours till the next problem drops. I'm not going to do it, not least because I'm a streamer and we are asked not to do anything while the thing is happening, while the leaderboards are live. But, okay, we're caught up. All right. Wow. That was a lot. Thank you. Thanks to everybody who was hanging out for that. If you enjoy this kind of stuff, this is okay. It's not usually quite this algorithmic. Normally, I'm here doing actual dev work on a game I build, and then on weekends, on Sundays, I am playing games. This last weekend, yesterday, I played a Year Walk from the same folks who did Lorelei and the Laser Eyes, one of their early games. It was really great. But for right now, it is 7 o'clock. That's about 2 hours longer than I usually go. I start at 1 o'clock Pacific. So I am going to wrap things up here. Thank you all so much for hanging out. Thank you for being here while I pounded my head against some of this code. And I will see you all at some point in the future. Bye for now, friends.